setting up our SpectraViz, we've got our Go Direct plugged in. It's reading as an absorbance. We need to make sure that our absorbance is going to be the right level, so we're going to click on absorbance, and we're going to change the wavelength. The wavelength for the color that we're going to be using should be about 625.7. So I'll type in 625.7, and that's okay. The mode should not be full spectrum, so I need to change that. We're going to change that so that it is a time-based entry. At 0.5 samples per second, an interval of 2 samples per second is fine. The duration of 200 seconds will be totally appropriate. That's fine for this experiment, so we can click OK for that. Now it's reading all the things we want. We're noticing that right now the SpectraViz is empty, and so it's showing just a nice number of absorbance. We can calibrate the device by going to Sensors, and we can go to Calibrate, and we're going to calibrate it. It will take a dark sample. That's with no cuvette in there. For a minute, it will ask us to let the lamp warm up. At some point, it will become bright enough that we can skip that warm up. And now it says place a blank cuvette in the device. So indeed, we're going to do that. An empty blank cuvette. And we will hit Finish Calibration. Once we've calibrated the device, it's ready for us to be able to use for our experiment. So we're okay. And now we're ready to be able to go. Notice at this point, the green arrow is ready for us to be able to do its thing. We have 5 milliliters of a green dye produced by creating 5 drops of green with 5 milliliters of liquid. I'm going to transfer enough into another pipette or another graduated cylinder. That will take what we need. And I am going to rather quickly add 2 drops of some bleach water. Now, this bleach water was made by taking some bleach and diluting it 50-50 with water so that it's not overly strong. So I'm going to put 2 drops in, and I'm immediately going to pour that into my cuvette, and then I'm going to immediately get it into our system. And now I can hit play. You'll notice that the absorbance value should be around 2 or above. Now we're going to let this thing go. We're getting readings over on the side, time intervals here, and readings are there. As you're looking at it now, you might be thinking, this is producing a fairly linear line. Maybe it's going to be a first order. Well, we'll talk about how we can determine the order after we've gotten our sample. If the absorbance values are not above 0, you're going to have problems with being able to determine order with the graph because it's going to need a natural log, and those will not work. So if that happens, we should make sure that our dye is more concentrated. 5 drops of dye in 5 milliliters of DI water work pretty well. We're starting to see that we're getting a little bit more of a curve, indicating to us that this is not likely the 0th order. And now we've completed it. We've gotten our graph, which again is producing this very interesting curve. It's not a straight line, so we can test what order this is. by doing a little bit of manipulation of our data. If it's a first order reaction, then we will be able to tell that involving a natural log. So let's check this, and here's what we can do. We're going to take a look at the XY component up here. We'll click on that. We're going to go to Table. We're going to create a new calculated column. This column will be a column with the equation that we want. So the equation we need is going to be a natural log of X. There it is. We'll click OK. That graph looks a lot more straight. There's a little bit of curve up at the top. That could be a small amount of error, but that's looking like it's probably a first order graph. To check that, let's go back to the XY column again. This time we'll click on Table. We'll do a new calculated column. If it's a second order reaction, then what we need is an A over X. So we'll scroll down to the A over X. Here it is. And press OK. That is not a straight line. That's a very nice curve going up this way, indicating to us that probably this is not a second order reaction. So once again, comparing our original data set, which had a curve to it, and that which would be for a first order reaction, which is a pretty straight line, and that which would be for a second order reaction, which is again a nice curve. We'll go back to our first order reaction indication, and we can now add a line to show us this best fit. And the way we'll do this is rather simply, we're going to go up to Analyze. We're going to add a curve fit. We want this set of data. And we're going to make our fit line be linear. Now we have the equation for the line and our M and B and our correlation, which is 99.8%. And so we can pretty confidently use this data to say that this was a first order reaction.